For this experiment, you're going to be given an unknown liquid and an unknown solid. You're going to perform several tests on your liquid and your solid, and at the end you should be able to identify which specific liquid and solid you have. So in the beginning they are unknowns, you don't know what they are, but after you have your measurements for different physical properties of your compounds, you can use the table that you have in your book, and you can actually identify your unknown compounds. So the physical properties that you're going to be looking at, it's solubility, density, melting, and boiling points. Those physical properties are properties that we can actually measure without changing the composition of the compounds. So when you have a chemical change or a chemical property, you can measure or determine a chemical property based on a chemical change. But what's happening in that case is that the actual substance that you have in the beginning, it's being converted to a different one. And this is not happening in our experiment. You can determine the solubility of a solid, and your solid is still going to have the same identity. The density, you're not changing the composition of your compound either while measuring the density. And the same thing is going to happen with the melting and the boiling points. In page 77, you have a table that lists the properties that we're going to be looking at for different substances. So I made here a simplification of your table, and I'm using only acetone and phenylbenzoate. I have acetone, that one. So these numbers that I'm writing here, they come from the table that you have in your book. So you have your density values, melting point, boiling point, and then you have solubility. For solubility, you have W, C, and E. This is water, cyclohexane, and ethanol. Three different solvents that you're going to be using to determine the solubility of your unknown compounds. The S means soluble, the I means insoluble, Sp is partially soluble. So for example, acetone, the first one, it's soluble in water, soluble in cyclohexane, and soluble in ethanol. So you can use the table to compare like your experimental results for your unknown liquid or your unknown solid, looking at the solubility that you have here. For acetone, you have a boiling point equal to 56, a melting point that is a negative number. So you can actually look at the melting boiling points and you can determine the physical state of your substance. Look, if acetone has a melting point of a negative number, melting point is the temperature at which a solid becomes a liquid. Negative 95, it's a number that is smaller than room temperature. Room temperature should be like close to 19, 20, 21 degrees. So negative 95, if it's way below room temperature. So if you have a negative melting point, it means that that substance is actually a liquid at room temperature. For acetone to be a solid, it has to be at negative 95 degrees. Anything that is higher than negative 95 will convert your acetone to an actual liquid. So 20, it's a temperature that is higher than that negative 95. And what that means is that at 20, your acetone is going to be a liquid. So you can actually find out the physical state of your substances by looking at your melting points. So you have your phenyl benzoate here, the second example, and for that one you have a positive melting point. It means that at 20, which is lower than that one, your phenyl benzoate is a solid, and it will be a solid all the way until the temperature reaches that amount, 71. Okay? So you have to heat up your phenyl benzoate all the way to 71 before that compound goes from a solid to a liquid. So melting point we're going to be using for your solids. Okay? We cannot determine a melting point for a liquid. Melting point for the solid, and then boiling point for the liquid. Boiling point is the temperature at which your liquid becomes a gas. Okay? So water, you have water at room temperature as a liquid. So for water to be converted to a vapor, you have to heat up water all the way to 100 degrees, which is the boiling point for water, and then water will start evaporating. So for your liquid here, acetone, that boiling point is 56, which means that your acetone, which is a liquid at room temperature based on your melting point, will remain as a liquid until it's heat up all the way to 56. That's your boiling point for acetone, and at that point your acetone will be converted to a vapor. So now, as part of your procedure, you have, first thing, we're going to be determining the solubility of your liquid and your solid. So you're going to prepare 6 test tubes. 2 for cyclohexane, 2 for water, 2 for ethanol. So you have 2 sets with your 3 different solvents. And now you're going to test in your 3 different solvents, the ones that I have here in my box in blue. You're going to test your solid. And then the ones that I have here in green, in the box green, you're going to use to test the solubility of your liquid. So you're going to put 40 drops of each solvent in your 6 test tubes. So you have 40 drops of cyclohexane in one and in another one, 40 drops of water in one test tube, and you have a second one with water, and then 40 drops of ethanol in one test tube, and again 40 drops of ethanol in a second test tube. When you're testing the solubility for your solid, look, you're adding 40 drops of your solvent, okay? The one that you're trying to use to dissolve that solid. 40 drops, it's about 2 milliliters, which is a small amount of your liquid. If you add too much solid, even if your solid is soluble, since you have too much of it, the amount of solvent that you have is not going to be enough to dissolve that solid. Okay? So you have to be careful, and you have to add a small amount of solid into your test tube. So you have your 3 test tubes with your cyclohexane, the water, and the ethanol. And now you're going to place a small amount of your solid in cyclohexane, small amount of your solid in water, small amount of your solid in ethanol. You're going to use a glass rod to stir your solid. Make sure that you clean the glass rod before you move to the second test tube and to stirring the third one. Now for the solubility of your liquid, you have 40 drops of each solvent in each test tube, and you're going to add between 8 to 10 drops of the liquid in each test tube. So your unknown liquid, 10 drops here, 10 drops in the test tube with the water, 10 drops in the test tube with the ethanol. Look, if your solid dissolves entirely, it means that it's soluble. If part of your solid, so you have to make sure that you know like how much solid you're adding. Something that is partially soluble, you will see that part of that initial amount of solid that you added will dissolve, but not all of it. So you have to make sure that you kind of remember like how much solid you're adding into your test tube. If it's insoluble, you will see that you will stir your solid and your solvent with your glass rod and nothing will happen. Like the solid will remain inside your test tube entirely, the same amount that you added in the beginning. For your liquid, this one you have to observe very closely. If your liquid is soluble, when you look at your test tube with your solvent and the liquid, the unknown liquid in it, it will look completely clear, like you have a pure substance. If it's partially soluble, you might see some bubbles in there, or you might see like you can actually see your liquid moving inside of your test tube where you have your solvent. If it's insoluble, you will see two liquids. You will be able to see like the division between one of your liquids and the other. Make sure that you copy your observations in your lab manual. Okay? If you think it's soluble, insoluble, or SP for partially soluble before you clean everything. Now, for the ones that I have in my blue box here, the ones where you have your solid, keep the test tubes where you have solid inside, which means that you're keeping the test tubes where your solid is insoluble. Okay? Make sure that you don't throw away those test tubes. You're going to keep them because you're going to use them for the density, to determine the density of your solid. You only need the ones where the solid is insoluble or partially soluble. You can use those too. So I have part two, and I'm going over density for the solid first because we're using your test tubes from part one for this one, so you don't have to repeat the same thing again. So you have your test tube where the solid is insoluble, and you're going to look at, we're not actually determining a number for the density, we're estimating the density, like if it's higher than or lower than a specific value. So you're going to look at your test tube where the solid is insoluble, and you're going to see if the solid is floating on top of that solvent. For example, if you're looking at the test tube and your solid is insoluble in water, that solvent is water. The density for water, which you have in your lab manual, it's 1 gram per milliliter. And you have the table in page 73. You have density for water, cyclohexane, and ethanol. So you can use the same approach with all three solvents. So if you have your solvent, it's water, and your solid didn't dissolve in water and it's floating on top of water, I'm looking at the left side of my diagram right here. It's floating, yes. If your solid is floating in water, what that means is the density of your solid, it's lower than 1. Okay? Things with a lower density will float if they have a greater density than your solvent, they will sink. Okay? So on the left side, I'm looking at the ones that are floating. So if your solvent is water, the density for that solid will be less than 1. On the contrary, if you see your solid sink in your test tube where you have the water, it means that the density for that solid is greater than 1. So you can use the same thing with your cyclohexane and with the ethanol. If your solid is insoluble in ethanol, for example, you have the density for ethanol as 0.789 in your lab book. So if the solid is floating in ethanol, it means that that density for your solid is less than 0.789. If the solid sinks in ethanol, it means that the density for your solid will be greater than 0.789. And that number for cyclohexane here is not correct. That should be 0.778, not 0.788. It should be 7. So when you're looking at your test tubes, make sure that you copy your observations. You have your solid, soluble, insoluble, and then if it's floating or if it sinks in the specific solvent. So make sure that you write down the solid was floating in water or it sank in ethanol. Copy everything in page 81. Now, another thing, you might have something like your solid, part of it is floating and part of your solid sinks. What that means is that the density for that specific solid is going to be very close to the same value that you have for the solvent. For example, if your solid in water floats part of it, but you have part of that solid synced also in your test tube, it means that the density for that specific solid is going to be very close to 1. Next part, you're determining, oh, this is still the same part. We're looking at the density, but this is the density for the liquid. So for this one, you're going to have a clean beaker, clean and dry. You're going to determine the mass of your beaker, empty. So place your beaker in the mass balance. Make sure that you copy all of the numbers in the mass balance in your lab book. Now you're going to use a pipette, and I will demonstrate in the lab how to use the pipette. So you're going to be using the pipette to measure exactly 10 milliliters of your liquid. Those 10 milliliters of your liquid you're going to transfer now into the clean beaker that you weighed empty. So now you're going to have your beaker, the mass of your empty beaker that you copy, and now you're going to have a new mass, which is the mass of your beaker plus the 10 milliliters of the liquid that you're adding. With those two numbers, you can calculate the mass of your liquid and you can calculate the density. You're going to have a mass of the liquid and a volume, and with those numbers, you can get the density of your liquid. So for your liquids, you will actually have a numerical value. For the solid, you have an estimated value greater than or less than. Okay? But for the liquid, you are going to do the calculation to actually get the density value for your unknown liquid. Melting point. You're determining the melting point for the solid. Melting point, we're going to be using a melt temp. So it's an instrument that we use to determine like that temperature where your solid goes from being a solid to a liquid. So in the lab, in the beginning, I will demonstrate how to use the melt temp, how to set it up, and how to determine your melting point. And I will show you how to fill your capillary tube, which is what we use to place the solid, and that capillary tube goes inside the melt temp, which is the one that you're using to determine the temperature. So I will demonstrate, and you should pay attention so you know what you're doing for that part. And then for the boiling point, you have a diagram in page 75. So you're going to set up everything besides the test tube where you have your liquid. That part I will tell you what you have to do, and then you will place your test tube in the clamp following the diagram that you have in page 75. But again, you're going to be measuring 5 milliliters from your unknown liquid. Those 5 milliliters goes into the test tube. And then that test tube goes into your setup that you have illustrated in page 75. And I will try to have one for you so you can actually look at it in the lab and it will be easier for you to set up everything. And using that, you're going to be determining the boiling point, which is that temperature at which your liquid is going to evaporate, okay, or it's going to be converted into a vapor.